For our first Excel example, we're going to take a look at the trial and error method example in the book. I've set my workbook up as follows. I've got the production quantity, which I denote with a variable X, the projected profit, which is denoted with a variable C, production hours, variable A, and feasible solutions, which I use a variable B. Our next step here is to enter the input data that we are given with the problem. We are told that we have a profit of $10 per unit, so I simply enter 10 into this cell. Production hours of 5, and finally we are given a constraint of 40 hours. So I'll enter 40 right here. We cannot exceed 40 hours. So our next step is to take a look at our production quantity, our decision alternative. What can we change or modify? X, I'm going to start just entering a few values here, 0, 1, 2. Now I'm going to take full advantage of Excel. If I highlight my 0, 1, 2, and 3, and then look down at this lower right-hand corner here at this big green box, I can click on that box and drag it down. As you can see, it's going to continue on in the pattern that I'm going. If you look to the right of my crosshair, you can see 5, 6, 7, 8 as I move down. The value you see there is what you'll see in the cell as soon as I let go of my mouse. Now we'll go to 14. That's plenty. Okay? See, we've entered our values here, making use of Excel's functions. Our next step is going to be to enter formulas. I'm going to calculate my profit here based on $10 per unit and use my production quantity. I simply enter an equal sign for formula equals my production quantity multiplied by my profit. Now I want to start to lock values in, lock cell references in. We're going to use both relative and absolute cell references. Relative cell references mean that they're relative to the cell that I'm working with. For instance, in our example, the production quantity is going to be relative to the cell that I'm working with. However, I want to stay in column A here. So I want to lock in my A. I'm going to put a $sign in front of it, but I want this 8 to change. I want my row to change as my formula moves down. Now looking at the profit though, I always want $10 of profit per production unit. So I don't want the column or the row to change here. I want to lock in both B and 6. Now we're going to take a look at production hours. It's a new formula, enter an equal sign, and again it's production hours multiplied by our production hours, or 5. Okay. We need now to enter our relative and absolute cell references. So again, we want to stay in column A, but we want our row to change as our production quantity changes. Then looking at our production hours, we always want it to be that 5 or whatever value I may have for my production hours. So I want to lock in both the row and the column. Now from here we can just copy our formulas. I select both of them, go over to my green box in the corner, drag all the way down to my last production value of 14 and let go. Now quick little formatting thing here. You can see projected profits are a lot easier to read because they are centered in the column. Production hours are on the right, a little bit more difficult. I'm just going to select this. I'm not sure how our feasible solutions is formatted, so we will err on the side of caution and take care of it too. Select both of those, go up here to my center content button, click that, and we're good to go. Okay, now we want to make sure that we have properly entered these formulas. We want to double check a couple of them. So I'll just double click on this one. Yep, my production quantity is relative to the cell I'm working in. We move down, multiplied by profit. That one's good to go. Let's take a look at one of our production hours. Double click here. Got production quantity of 8 multiplied by my 5. That one is good as well. Next, we want to see which of these are feasible and then from there determine which our optimal or best option is. So the formula we will enter here becomes an if-then statement. And we start with an equal sign, then type the word if, open parentheses. So if the production hours we calculated is less than or equal to our feasible solution of 40, then I want to see, I need a comma here, my comma is the then. I want to see the word yes. That means I have a feasible solution. If not, I want to see the word no. Okay, end parentheses. However, I'm not quite done here. My D6, this red highlighted cell of 40, that needs to be an absolute cell reference. We want to lock that in. It always has to be less than or equal to 40. So put my dollar signs in there. My formula looks good. Click enter. And highlight this one. Grab my lower right corner, the green box. Click, copy it all the way down to my production quantity of 14, my last one. Let go. Let's see what we've got. We have yeses and nos. Okay, now if I go down to my last yes, we'll see how to read this. It shows that in our example, the optimal feasible solution in this trial and error method model is a production quantity of x equals 8.